Okay, year 10. So for our next few lessons, we're going to be doing some work on trigonometry. Now, trigonometry, all of you will have looked at in year 9, and some of you, depending on what class you're in, will have looked at in year 8. We haven't really done any of it so far this year, and that's why we're going to revisit it now. It's particularly important because at the start of year 11, probably, we'll be doing some kind of new trigonometry, which is a bit harder. And so before we go on to that, it will be really helpful if you've all got a really solid understanding of this. So to start with, I'm going to hopefully go quite slowly. Some of you might not need to listen to all of this bit at the beginning, but just we'll see how it goes. So to start with then, trigonometry is a bit of math that's to do with the relationship between sides and angles in triangles. That's all you need to know for now. And then this is super important. There are 3 ratios between the sides and the length, and those are the sine ratio, the cosine ratio, and the tangent ratio. Now, normally you'll refer to them by like their shortened versions. So instead of sine, you might say sin. Instead of cosine, you might say cos. Instead of the tangent ratio, you say tan. So we have sin, cos, and tan. Okay. Now, the reason this is useful, or not even the reason this is useful so far, we're going to get onto that. What you need to know is this. So I would suggest at this point you kind of pause the video and copy this entire slide as it is down now onto the paper you're working on, onto your book or whatever. So what this is saying then is that when the sine ratio refers to the relationship between the opposite and the hypotenuse, we'll get to what those are. The cos ratio, or cosine, refers to the relationship between the adjacent and the hypotenuse, and we'll get to what those are. And then finally, the tan ratio, the tangent ratio, refers to the relationship between the opposite and the adjacent, and we'll get to what those 3 words, opposite, adjacent, and hypotenuse, mean in just a second. Useful point here, just before we move on, is the acronym SOHCAHTOA is really useful just to remember kind of how this works. So sin is S-O-H, so SO, CA is cos A-H, and then TOA is tan O-A. Okay, so SOHCAHTOA is how you can remember all of this, because this slide here you do just need to know really well. Okay, so reasonable question then. What are the hypotenuse, the opposite, and the adjacent? And these are the names given to the sides in any right-angled triangle. So we're going to look at now at how we label them. So first of all, the hypotenuse is the longest side. It's opposite the right angle. So where's my pen? So here is the right angle, and this side here is opposite it. This is the hypotenuse. I'm just going to write here. Okay. Next bit, the opposite. So the opposite is the side opposite the labelled angle. So here my angle is labelled X, and this side is opposite it. This is the op. And then down here, the final side is called the adjacent. And that word adjacent means next to. And so we can see here that this side 6 is next to the X. So this here is the adjacent. We'll do a couple more examples of labelling now. The second example of labelling then, let's start off with the hypotenuse. The hypotenuse, the longest side opposite the right angle. So as before, here is the right angle. This is opposite it, so this is our hypotenuse. The opposite is opposite the labelled angle. This is my labelled angle. This side is opposite it, so this is the op. And finally, the adjacent is next to the labelled angle. So this one here is the adjacent, hip, op, and ouch. And then final one just on this for the moment. So here we have got, if we start by labelling the hypotenuse, so this is my right angle. This then is the hypotenuse. This is the angle, this is the labelled angle. So this side is opposite it. and this side is next to it, so it's the adjacent. And then, right, let's just do one more. I lied. This final one then, in terms of labelling. So our hypotenuse here is our right angle. So this is our hypotenuse. Then this here, this is unusual, because not unusual, this is just different to the 3 previously. Here the angle is 31 degrees, okay? But this is still the relevant angle. So I'm looking for the side that's opposite that 31, which is this one. So this side, it's the opposite. And then the side that's next to the labelled angle is the adjacent. Okay, so year 10, in terms of like the actual steps of how we find a missing side, I'm just going to talk you through them. Step number 1 is this: we're going to label the sides, and we're going to do that in the same way we've just been practicing. So we're going to label, where's my pen, the hypotenuse, which is here. We are going to label our opposites. The opposite is opposite the angle of 50, so this is our opposite. And we're going to label our adjacent to the angle. So that's step 1, we label our sides. Step 2, and this is a little bit harder, we need to choose if we're going to be using sin, cos or tan. And to do that, we can think about so, ha, toa. Now these 2 questions I've put here, I think are super, super important. You are thinking to yourself, what do I know? And what do I want to know? That's always what's in my mind if I'm doing a trigonometry problem like this. So I'm thinking in this case, well, I know the hypotenuse. I want to know the adjacent. So I know the hypotenuse, I want to know the adjacent. And because of that, it's going to be cos, because cos, ha, is to do with the adjacent and the hypotenuse. That's super, super important. Next step. We write out the formulas. Those formulas that you should have written down earlier, I want you to write out the formula that you're going to be using for a particular question. So in this case, my formula is going to look like this. It's going to look like cos angle equals adj over hip. Like that. Horrible writing, but you get the idea. Step 2, or step 4 rather, we substitute in the values from the question. So let's rewrite this out. So cos. Now instead of writing angle, I'm going to write what the angle is. The angle is 50, so it's cos 50 degrees. So cos 50 equals. Then let's have a look at our 2 sides. So our adjacent is x and our hypotenuse is 8. So my adjacent is x and my hypotenuse is 8. So now this is an equation that can be solved because this equation just says cos 50 equals x divided by 8. So to find what x is, all I need to do is times by 8 because the opposite of dividing by 8 is timesing by 8. So to find x in my calculator, I'm going to do 8 times cos 50. 8 times cos 50, working that out now, is, oh, where's my pen gone? 5.14 to 2 decimal places. I'm going to say 5.14 centimetres to 2 decimal places. Oh, pen just goes off the screen now, I can't quite write like that. So 8 times cos 50 equals 5.14 centimetres, and that's the answer correct to 2 decimal places. We'll try a second example of that now. Okay, so we'll go through the same steps again. Step 1, we're going to label our sides then. So this time round we've got our hypotenuse. This is 30, so this side is our opposite. And then this side down here is our adjacent. Second step, we can remember choosing whether we're using sin, cos or tan. So in this case, what do I know? I know the opposite, I want to know the adjacent. So I'll write out Socrates up here to help us choose. So I'll say that again. I know the opposite, I want to know the adjacent. Because of that, it's going to be toa or tan. Next step, write out the formula. So this time around, my formula is going to look like this. It's going to look like tan angle equals op over adj. After that, we rewrite this using the numbers from the question, the values from the question. So it's going to be tan, the angle is 30, so tan of 30 degrees equals the opposite, which is 8, over the adjacent, which is x. Now, at this point, oh, sorry, I hadn't realised I would have gone over that. That's annoying. At this point, I'm going to rewrite the tan 30 equals 8 over x, but just so you can see a little bit clearer. Sorry, year 10. This looks different to what we had on that previous example, and the fundamental difference here is that the side we are looking for is on the bottom of the fraction. So there's kind of two steps needed to rearrange it. So the first step would be to multiply both sides by x. So when I multiply both sides of my equation by x, I get x times tan 30 equals 8. Then to find what x is, I need to do the opposite of timesing by tan 30, which is dividing by tan 30. So x equals 8 divided by tan 30. Now, quick side note, you can get away with just sort of learning this rule here. The missing side on the top you times, the missing side on the bottom you divide. But this rearrangement here is the steps that are going on. So now we've got x equals 8 divided by tan 30. You simply get your calculator out and you type in 8 divided by tan 30. And when you do that, you end up with 13.86 centimetres. So you get x equals 13.86 centimetres. It's going to be 6. And again, that answer I've given it to 2 decimal places. Okay, so that's it, year 10. Hopefully those examples will have been helpful. Sorry, they're a little bit messy. I'm getting to grips with my new tablet at the moment, trying to figure out how to write things well. But hopefully that's been helpful. So you're going to be practicing some questions that look like that today, and then tomorrow we'll move on to recapping finding missing angles using trigonometry. As ever, let me know if you've got any questions.